think for a better connection, I'll switch off my camera during the presentation. So,
Sure, madam.
very good evening to all of you, and welcome to my green talk on harnessing circular economy for sustainable construction in Sri Lanka. So I will be talking about the basics of the circular economy before I talk about the construction industry, because yes. Okay, so this is my content of the talk. So I'll give you an introduction to the circular economy and the principles of the circular economy, and I will be guiding you to the construction landscape, global and the national level. And we will be talking about the circular strategies in construction, followed by the circular economy initiatives that are being practiced in Sri Lanka currently. So before I talk about the circular economy, so-called circular economy, I would like to introduce you to the current economy. So this is the so-called linear economy. Sometimes we refer to it as the take, make, waste economy, which is a system where the resources are extracted to make products that eventually end up as waste and are thrown away. So the products and the materials, they are generally not used to their full potential in a linear economy. And as the name suggests, so it always moves in one direction, that is starting from the raw materials to the waste generation. So it's actually a polluting system that degrades the natural systems and is the driver of the global challenges, like we are talking about the climate change nowadays, and also about the biodiversity loss and some more consequences. So the Industrial Revolution, we know that this started in 19th century. So this has laid the framework for this linear economy. And however, it has brought many benefits, like for the first time, the goods were able to be mass produced. And on the back of this economic transformation, the industrialized countries, they became societies of abundance, and also the world population soared and many millions were pulled out of poverty. So these are the plus points of this linear economy. And the global development was only possible by extracting these finite resources, so the natural resources, and degrading the natural capital in order to generate this economic value. So over time, we have learned to do this in more and more ways to create ever more advanced products. And however, despite those positive points or the plus points of the linear economy, there are negative effects of this approach in the form of environmental damage and the loss of valuable materials, which is very much clear for us today. So they are driven by the mismanagement of resources and land in industries across the economy, including the agriculture, construction, and the transportation. The way our economy functions is destroying the natural capital on which it depends. So this can be clearly seen. This is seen in the soils that are being degraded, and also the oceans that are being polluted, and the biodiversity that is being lost. Not only that, beyond that, we see that the fresh water that is drying up and the forests that are being felled. So a transition to a circular economy will be crucial to allow us to thrive in this in the future. So that is why we are talking about the circular economy. So if you look into the circular economy concept, it's even though we say it's a very new concept, but this has been started earlier in 1970s, even earlier that. And this is not a very new concept, but if you clearly observe the nature, so you can see that the nature is operating in a very circular manner. So you're starting, if you, for instance, if I give you an example, like if you take the plant, so that the nutrients are and the water is absorbed to the plant, and then the plant is grown, and then whatever the leaf or whatever the other material that is becoming litter, and then they will be degraded and the nutrients are back absorbed to the soil. So this is happening in the circular manner. So this is simply what we meant by the circular economy. So we are trying to mimic the nature and apply it to the whatever the products that we use. So it is a model that moves away from the traditional take, make, dispose approach And it's a system where the materials, they never become waste, and the nature is, again, on the other hand, it is regenerated. So what we are trying to do through the circular economy is we are trying to make or keep the products as well as the materials in circulation through processes like we are trying to maintain, we are trying to reuse, refurbish, or remanufacture, recycle, and whenever or applicable, we are trying to compose these materials. So the circular economy trying to tackle the climate change and other global challenges like biodiversity loss, the waste generation and the pollution by decoupling the economic activity from the consumption of the finite resources. So moving on, so if I give you more details about the circular economy, so this is basically based on three principles. So the first principle is the eliminate waste and pollution. Then second principle is the circulate products and the materials at their highest value and the regenerate nature. So I will be talking about these principles. So if you move to the first principle, that is the eliminate waste and pollution. So this is if we take the raw materials from the earth. So we make products from them, and then what we do is we eventually throw them as away as the waste. So much of this waste, what happens is that ends up in the landfills or else in the incinerators, and it is lost. So this system actually cannot work in the long term because the resources on our planet are finite, even though we have a false premise saying that, okay, assuming that we have infinite natural resources on the earth. Currently, we are consuming like 1.7 times earth of the natural resources. So actually why this problem happens and the solution, that is again starting with the design. So if I give you an example, so if you take maybe a wrapping of a cookie packet, so biscuits maybe, so this might have been produced using multi-material flexible packaging, so which cannot be reused or recycled or maybe composted. So what happens is that it will end up as a waste somewhere in the environment. So for the products like this wrapping, so waste is built in as they are designed to be disposed. So even though it sometimes seems like waste is inevitable, so sometimes we see that, okay, we cannot avoid the waste generation in certain situations, but waste is actually the result of design choices. So it's a flaw of the design. So there is, if you look into the nature, there is no waste in nature. So it's just a concept that we as the human being have been introduced. So from tiny short-lived products, maybe the cookie wraps, all the way up to seemingly permanent structures like buildings and the roads, massive structures that we are talking. The economy is filled with things that have been designed without asking these questions. So what happens to this at the end of its life? So if we shift our mindset, we can treat waste as a design flaw. So in a circular economy, a specification for any design is that the materials re-enter the economy at the end of their use. So by doing this, we take the linear take-make waste system and try to make it circular. So there are many products that could be circulated by being maintained or maybe shared, or sometimes we can reuse the material products and also repaired to a certain extent and refurbished, or sometimes you can remanufacture them. And if none of these options are possible, then as the last resort, you can recycle or dispose. So if you take food and the other biological materials that are safe to return to the nature, that can generate or regenerate the lands, so we can fuel the production of new foods and materials. So in the circular economy, what we are really talking is with a focus on the design, so we can eliminate the concept of waste. So that is the basic fundamental in the circular economy. So I just wanted to give you some examples for those who are not having an idea at all about the circular economy and its applications. These are not related to the construction industry, but These are very simple examples that we can think of in day-to-day life. So if you take the food packaging, we know that it is generating a lot of waste. So maybe you see that shrink wraps, that when you go to the supermarkets, you can see a lot of shrink wraps where they are using it to pack the vegetables or sometimes fruits, etc. So on your right-hand side, what you can see is a fruit, an avocado, which is without a shrink wrap, but it is having a layer of edible plant-based coating applied. So this is called the appeal. So it's a product that is coming with the edible layer. So it is free of this artificial or synthetic uh, packaging. So this is a very good example for the application of the circular economy in the food packaging. And the second one, in the middle, you can see a soap bar, or we can say it as a shampoo bar. So if you have heard about this company, a very famous one, this is called the Lush. So this is, they have actually redesigned some of its liquid personal care products. So they have a massive number of products. So liquid personal care products, they are sold, or they are to be sold as a solid formulation, so that they don't want to go for these liquid products which is packed in the plastic bottles or other forms of packaging. And if you look into the textile industry, so there is a very famous textile industry. It's called the Daiko, an international one. So they have developed a technology for dyeing textiles without using the water, so that they can eliminate the toxic wastewater generation. So these are some of the applications, and that is all about the first circular economy principle. And the second principle is about the circulate products and materials at their highest value to whatever the degree that we can reach. So that means keeping the materials in use either as a product, or when that can no longer be used, as components or raw materials. So in this way, what we can achieve is nothing becomes waste, and the intrinsic value of the products and also the intrinsic value of the materials can be retained. So we can have several ways the products and the materials can be kept in circulation. So in the circular economy, we are discussing about a so-called diagram, the butterfly diagram of circular economy. So I'll be showing this in a later slide. And so here is just an example for companies who are designing for circulation. So there are many innovative companies in different fields that they are having different products with the recirculation in mind at the design stage. So this is a very good example. It's called Ecovative, where it makes compostable packaging from the agricultural byproducts. So the parts of the crops that cannot be eaten, that is coming from the mushroom cultivation. So you know that there are bags filled with the media that is required to grow the mushroom. So that once you get the harvest, then you need to discard whatever the medium that you are using. So they are using this medium plus the mycelium, this white color mycelium, which is binding the wooden particles, so that they are molding it into different shapes and then use it as a packaging material. So this that's about the second principle. So this is about the third principle in the circular economy. So that is the regenerate nature. So by moving from take, make, waste, linear economy to a circular economy, then we support the natural processes and try to leave more room for the nature to thrive. So what we can do is, by shifting our economy from linear to circular, we can shift from the focus from the extraction, that is the natural resource extraction, to regeneration. So if I give an example, so we can employ the farming practices that allow nature to rebuild the soils and also to increase the biodiversity and return biological materials to the earth. So if we move to such a regenerative model, then we begin to emulate the natural systems, and there will be no waste that we can see in the nature. So this is a very good example for the regenerate nature. So there is a company called the Natura in South America that is the largest cosmetic company, and this is the fifth largest beauty company in the world. So where it produces huge range of products, including soaps, creams, and shampoos, all of which rely on the rich biodiversity of the Amazon for ingredients as well as for the materials. And they are also, plus they are using the biointelligence of the indigenous communities that they are living here in the Amazon. So what they do is the supply chain, their supply chain includes almost 40 types of biodiversity assets. Those are based on the plant-derived ingredients and the involvement of about 7,000 families. So a key element of this Natura's building or the business model is the concept of the standing forest economy. That means, in simple terms, if I explain, that is that a tree has much more economic value standing than it is felled. So based on this economic or the business model, they are working, and so that using this philosophy, they have preserved over 2 million hectares of the Amazon rainforest with a goal of increasing this area to 3 million hectares by 2030. So that's all about the introduction to the circular economy and its principles. So if I talk about the construction landscape, the construction sector, we know that it contributes substantially to the global GDP and the employment opportunities, representing roughly 10% of the workforce, and is estimated to account for 14.7% of the GDP in the year 2030. So we know that the growing GDP raises the need for the construction and the consumption of materials to over half of the world's raw materials, and 40% of energy, and 1/6 of freshwater withdrawals, all of which are not sustainable. So this is also causing a rise in investments in energy efficient buildings and the global resource consumption and associated emissions. So significant portion of these resources are wasted during the construction and the demolition of the structures, or maybe the buildings, which we refer to as the construction and demolition waste, or C&D waste, which is forming 30 to 40% of the world's solid waste generation and containing 50% recoverable and recyclable materials and the components. So only 20 to 30% of such material and the components are recovered and recycled. And the remaining goes to the landfills, either the landfills or the dump sites. So we know that the construction industry, this is labeled as one of the largest consumers and the exploiters of natural resources, relies significantly on the environment for its raw materials, and they contribute to environmental pollution and degradation, where they impact on the ecosystems for project inception to demolition. So that is why the circular economy is widely argued to be adapted into the construction sector to aid in the realization of the UN Sustainable Development Goals as well. So this is, even though I mentioned that this is not a novel approach, but this is an innovative approach that has been developed over decades, and it's a regenerative and restorative system to untie the economic development from the resource depletion by reducing the raw material inputs, and at the same time by protecting the natural resources by relying on the renewable resources, eliminating waste and reducing the carbon footprint in the end. So circular economy, if you take it in the construction sector, that can be termed as a closed loop system that seeks to improve the resource efficiency, reduce wastage, and encourage the perpetual refurbishment, reuse, and recycling of the construction materials and components. And it employs the principles of conservation. So you might be very familiar with these principles of conservation, the 3R principle: reduce, reuse, and recycle, in order to reduce the consumption of resources and the materials, to increase the durability by optimizing the lifespan of materials as well as the components. Not only that, we design easy connections for disassembly as well as adaptability for reuse at the end of their function and to reuse the components and parts through the prefabrication at the end of life. So eventual recycling with the remainder, somehow it returns to the nature. So if you take the construction materials and the components and resources, they reach their end of useful life, and the circular economy turns them into the valuable economic resources. That is what is happening in the construction sector if we apply the circular economy. So further to that, if you take the global construction sector, so the global construction market size is somewhere around over 10 trillion US dollars. So if you look into the entire market, the leading markets are based in China, USA, India, and Europe. And the key trends in the construction landscape in the global level is the rapid urbanization, and also there are more initiatives related to the sustainable, or sometimes we call them as the green buildings. And also there are more and more technological advancements, AI, robotic, etc. And we see that there is a high trend in modular construction and prefabrication. And also due to the skilled labor shortages, they are pushing towards the automation. So if I just give you an overview about the Sri Lanka construction industry, so this is contributing to somewhere around 6 to 7% of the Sri Lanka's GDP. And the major sectors are the road constructions, housing, tourism, ports, and the water supply sector. So there are many challenges that we have been facing in the construction industry due to the economic crisis, COVID, and some forex shortages, etc. So, however, the workforce, this is a significant employment generator, but facing skilled labor migration, similar to some other countries. And the other problem is dependence on imported materials, which is affected by foreign exchange crisis. So this is just a comparison between the global and the Sri Lanka, the trends, construction. So if you look into different aspects like growth drivers, the global growth drivers are like urbanization, technological development, and sustainability. And in Sri Lanka, so infrastructure projects and housing demand. And what are the challenges that we are facing at the global scale? We are facing challenges with regard to the labor costs and the regulations. And with regard to Sri Lanka, so we are having economic instability and also some material shortages. And technology usage in the construction, so we see that there's a high technology usage in the global level. There you are using AI or robotic or some other software. And in Sri Lanka, we are using this from low to moderate levels. And the sustainability focus is very high in the global standards, so they are focusing much on the green certifications. And in Sri Lanka, of course, yes, we do have some sustainability focus, and this is emerging, so we do have some certification programs and organizations as well. So these are the challenges in both contexts. So at the global, you know that the rising material cost is there and the supply chain disruptions, and again, the shortage of skilled workers. And in Sri Lanka, again, the import restrictions are there, so it is causing material shortages. And also, if you look into the political and economic, so still there are some instabilities and high financing costs affecting the project initiations. However, despite those challenges, we do have some opportunities at the global scale. So growth in green construction and net zero buildings. And we are talking a lot about the smart cities and digital twin technologies, and also circular economic approaches. They have much advanced circular economic approaches, policies that are being developed, and still there is an opportunity for them to grow. And in Sri Lanka also, we do have a lot of urban redevelopment opportunities and rebuilding tourism infrastructure. And also there is a space, there is room for the public-private partnerships to attract investments. And again, we have a very big opportunity for the circular economic approaches. So I just wanted to include this slide just to highlight about the construction engineering sector. So we call this AEC activities, or that is architecture, engineering, and construction activities. So according to the literature, it says that the AEC activities in the world contributes to somewhere around 36 to 40% of the CO2 release. So therefore, it's really, really important that we have to invest and we have to research a lot on these AEC activities because there is a huge potential in reducing the waste and emissions in all the phases of the design, construction, and the demolition phases. So therefore, the circular economy is recently recognized as a possible solution to solve waste and emission problems in the AEC industry. So, however, today we are just talking only about the construction. And from here onwards, I just wanted to show you some circular economy strategies, whatever the approaches that are being practiced in the construction sector. So there are many different approaches available, but I'm just talking about few approaches and strategies. So the first one is the circular practices. So as I mentioned, so the circular economy is focused on the implementation of only a few circular practices that we call as a 3R strategies: reduce, reuse, recycle. But recently, it is stressed the importance of considering these 3R strategies and expanding them up to 10R strategies. Sometimes we are talking about 3R and 4R and again 7R. But here in the construction sector, we are nowadays focusing on 10R strategies. So 10R starts with the RO or R0, that is refuse and rethink. So whenever possible, you can refuse and rethink whether do I really need to buy this product. So in day-to-day life also, you can think whenever you go to the supermarket or to buy something, you can think twice and thrice, do I really need this product? So if it is not necessary, then of course you can refuse. That is meant simply by the RO or R0. And then the R1 is reduce. So I think it's very clear for you to understand. And the R2 is either resell or reuse. If it is possible, of course, you can buy yourself, you can reuse. Otherwise, if you can resell it for some other person, you can do so. And then if there is a small damage, of course, you can go for the repair. So that is R3, and refurbish. Whenever possible, you can refurbish and then use it. And if you want to remanufacture something, then you can remanufacture with the product or the material and then repurpose it. Maybe you are using it for one purpose, but maybe you can upcycle or do some changes and then you can use it for another purpose. And then recycle whenever possible. You can recycle it and you can make the same product out of it, or else we can go for another product. And then recovering or remining. So remining, I think as the word implies, so you are trying to mine it again. So these 10R strategies have been built upon this so-called Lansing's ladder, or we call it, very often we refer to this as the hierarchy for the waste management, which was introduced in 1979. So these strategies are ordered by the priority depending on their level of circularity. So that is R0 being the highest circularity levels. That means if you can refuse or rethink, that is the highest circularity level. So this is another approach, or we cannot really clearly say that it's an approach or a strategy, but this is very often talk or discuss about when we talk about the circular economy. So this is the butterfly diagram. So if you clearly observe this butterfly diagram, you can see there are two cycles, one in green and one in blue color. So we are introducing these two cycles, that is the technical cycle onto your right hand side and the biological cycle onto your left hand side, which is in green color. So in the technical cycle, what we do is you take the whole product as it is and then try to use it as much as possible. And whenever it is no longer being used, then what you can do is maybe you can dismantle it into separate parts and then see whether you can reuse those parts, or maybe you can repair it and then you can reuse it for remanufacturing another product or as recycle. So this is called the technical cycle. So for instance, if I take an example like maybe a mobile phone, so you can use it as long as you can and then see whether you can dismantle and take some parts of this, maybe the circuit, maybe the battery, and use it in some other application. So this is where we are talking about the technical cycle. And the biological cycle is very easy to understand. So whatever the biodegradable materials, there we are talking about the biological cycle. So what the biodegradable materials are returned to the earth through the processes like composting or maybe anaerobic digestion like biogas production, etc. So sometimes there could be, if I give a very simple example, so you just take a fruit and then you eat it, and whatever, maybe if it is overripened, you just throw it so that it is returned back to the nature through the composting or the biodegradation process. But there could be some other material that is circulated either through the technical or the technical cycle or the biological cycle, or maybe part of the product could be coming under the technical cycle, and the part of the product could be coming under the biological system. So there is also there. So if you carefully look into a product and see what are the possible solutions, or whether it undergoes the technical cycle or biological cycle, and then what are the feasible or applicable principles, or what are the options available, so that you can go up to the maximum usage of the material or the product. And another approach is, we call this as a building circularity. You might have heard about it. So this is where we focus on the materials flow during the whole life cycle of a building. So especially in the recycling process of the building materials and the components. So here you can see, despite the butterfly diagram. So in the circular cycle, in the building circularity, we see there are 4 cycles. So the biological cycle, which is depicted in green color, and below you can see the technical cycle. And on the other side, you can see the social cycle as well as the economic cycle. So this model contains both technical, biological, and social economic cycles. All 4 cycles are there. The circularity calculation of the biological cycle, that is built on the existing life cycle assessment methods as well as the data. And for the circularity calculation of the economic cycle, takes the existing life cycle cost, that is we refer to as the LCC method, and whatever the available data, and as a starting point. However, there's a problem with this building circularity diagram. So the social aspect is very hard to quantify. But we are talking about this as a circular economy strategy in the construction sector as well. And this is very easy to understand. So this is called the design for deconstruction, or DFD. So this is a key principle in applying the circular economy to the construction sector. So it involves designing the buildings in a way that it allows their materials as well as the component to be easily disassembled with the minimal damage to the product, and reused in the whole or as a part, and recycled more efficiently. So the ultimate goal for this design for deconstruction is to extend the material life and to reduce the waste generation, and to finally to lower the carbon footprint. So there are key principles involved in the DFD. So that is modular construction. So you might have heard about the modular construction if you are working in the civil engineering. So that is the prefabricated units that can be separated. And we can also think of the reversible connections. That means you can use the bolts, screws, etc. instead of using glues and the weldings. And the material labeling. So that is very good, because if you label your material, so that is easy for the identification as well as for the sorting. And we are also talking about the accessibility, that is the components easy to reach and remove. and design documentation, so that in order to support the future reuse and disassembly, so you can document all these. So why it is important? So what are the benefits of the TFT? There is, it can reduce the construction and demolition waste generation up to 30 to 50% at the global average. And also it encourages the material recovery and reuse. And you can see that it saves cost in the long run and supports the low carbon construction and green certifications. So the DFT in practice, so we can see that there are buildings with timber frames and there are some dry joints, and also you can see the steel structures designed for bolt-based assembly and disassembly. So I just wanted to show you one or two pictures of examples, the building examples who have designed for deconstruction. So this is a very famous one. It's called the Circular Pavilion in Paris, in France. So this is actually the purpose of having this building is as a temporary public exhibition space built entirely from reused materials. And this is another example. So I tried to find some examples from Sri Lanka for the design for deconstruction. So many of you might have seen this, but you might have not thought about it, what it is and why. So this is a very good example that I could find from the ancient architecture, in the Kandyan architecture. So it's called the Madol Kurupava, or we call this as Kani Mandala. You can see this in Ambaka Devala in Kandy. So this is traditional wooden king post used in the Kandyan architecture to secure multiple rafters without nails or without any adhesive, allowing for easier disassembly and reuse. And other than that, I heard about the use of timber joinery. So in the traditional buildings, they often employ timber joinery techniques that facilitated the disassembly and reuse of the structural components. So I couldn't find a picture, unfortunately. So if you take Sri Lanka as a whole, so it does not have widely documented large-scale construction projects explicitly designed for the deconstruction. However, there is a growing interest as well as a research focus on integrating these DFT principles into Sri Lankan construction industry in order to promote the sustainability and to align with the circular economy practices. So this is another strategy or approach in the construction sector, that is the use of bio-based and the locally sourced materials. So if you have no idea about what is bio-based and locally sourced materials, so bio-based means the materials which are derived from the renewable biological sources like hemp or maybe straw or bamboo or mycelium like fungi and timber, etc. And the locally sourced material means the materials which are harvested or produced near the construction site. So maybe the regional wise, so the stones that you can find in the nearby or in the near vicinity, or maybe the timber or the mud or whatever the earth that you use in the construction. So why you have to use them, the bio-based and the locally sourced material? Because it can reduce the embodied carbon as well as the transportation emissions. And on the other hand, it can support the local economies and reduce the dependency on global supply chains. So most of the time, very often, the biodegradable, renewable, and suitable for reusing or recycling. So that is why we need to focus, whenever possible, we need to focus on the bio-based and locally sourced material. But there are practical issues in using those bio-based and the locally sourced material. But that's why I mentioned, so whenever possible, you can think of these. And what are the circular economy benefits of the bio-based and locally sourced material is, as I mentioned, so you can, if you think of the circular economy principles like reduce, reuse, recycle, and regenerate, the contribution from the bio-based and locally sourced material is you can use fewer synthetic and non-renewable resources, and natural materials are often easier to reclaim, and also many can decompose or maybe repurpose safely, so that in the end it helps to regenerate the natural systems when responsibly sourced. So this is a very good example that I could find where it uses the bio-based and the locally sourced materials. So maybe some of you might have visited this place. It is called the Diabubula, or the Barbarian Art and Jungle Hideaway in Dabula. So this is an eco-retreat which was designed by a Sri Lankan artist, and it showcases they have used the reclaimed timbers, or they have utilized 100-year-old railway sleepers and locally sourced wood crafted on site. And also they have used the ramped earth walls that is constructed using local soil, providing thermal mass and minimal carbon footprint. And also they have used the bamboo and woven reed, so that is for the roofing and also for the wall paneling and aesthetic finishes, etc. Not only that, they have integrated the nature uh, into the structures because it is built around the existing trees, preserving the natural landscape, etc. So this is a very sustainable design where it emphasizes on the minimal environmental impact and in harmony with the nature. So I think I mentioned about the importance of using these bio-based and the locally sourced materials. However, there are challenges because the perceived durability and performance of these materials, or better certification and material innovation, are needed in some constructions. And also the availability. So this is limited availability. So if you go for massive construction, so that the use of the bio-based and locally sourced material would not be sufficient. So that those are the challenges that we face when it comes to the bio-based and locally sourced materials. And another circular economy strategy in the construction sector is this is nowadays very often discussed in the European construction sector, that is application of the modern method of construction. So we call this as MMC. So that is use of cost-effective and sustainable modern methods of construction with the assistance of building information modeling. So you might have heard about the BIM and you might have used it as well. So this includes if I say like offsite constructions, or maybe the prefabrication, and sometimes the modular volumetric construction, and embodies concepts that can assist in adapting the circular economy practices when applied. So if you take the construction off the site, what happens is, it ensures the cost savings and it reduces the maintenance, and also there will be more scope of reuse and recycling through offsite manufacturing of standardized modular components as well as the panels that are prefabricated and transported to the construction site and installed. So you can use demountable components and panels so that it allows the construction and the deconstruction faster and in a resource efficient manner. So this is again another topic that we are talking a lot nowadays. So these are the green building certifications where we use to evaluate and recognize buildings that meet a certain sustainability and performance standards. So if I just give you some names of the green building certification that we find in the world. So the lead is the US-based globally recognized certification system, rating system. And we do have the BREEAM, that is UK-based one, where it is one of the oldest systems which is focusing on the whole life building performance. And other than that, we have a well building standard that is basically emphasizing on human health and the well-being. Other than that, we have the German Sustainable Building Council, DGNB, that is having a holistic approach, including the life cycle assessment, economic and social cultural aspects. We do have the Green Star in Australia, so where it assesses the sustainability of buildings, fit outs, and the communities. And if you look into Sri Lanka, so we do have the Green Building Council of Sri Lanka rating system for built environment. And also if you consider about the building materials, and we have the eco-labeling system as well. So if you want to integrate the green certification with the circular economic principles, so that there is a very good blend in these two, green certification and the circular economy principles. So this is just a comparison between these two. So if you take the circular economy principle, first one, the material reuse and recycling. So we can see on your right-hand side, in that column, you can see how the green certifications address it. If you take lead about points for using recycling and regenerate source materials, and again, BREEAM emphasizes life cycle impacts, etc. And if you go for the design for longevity and flexibility, so there are certifications which encourage adaptive reuse and building resilience, and construction waste destruction reductions or lead, as well as reward waste management plans and reduction strategies. So we see that if you clearly look into the certifications, there are certain sections or criteria developed in order to reduce the material usage, reuse, recycling, and so on. And this is about another strategy or an approach that we can use in the construction sector, that is the circular design. So in the circular design, you can see there are many aspects that we have to consider, that we can consider. So the first aspect is the design for longevity. That means it implies making products that can last long and also durable. That is, that can be designed in such a way that they can last longer. And also we can think of the design for repairability. So that means it aims at the ease of repairing products or the services, popularization of the service and maintenance culture, and extending the life cycle of the product. Or else you can also, at the design stage, you can think of the design for disassembly. That means maybe sometimes AI production would lead to products which are ready for recycling or reuse at the end of the production. In some cases, or in certain cases, maybe you can also think of a design where you can focus on the recycling. So that is when the designers use only the materials that can be reused. So this cannot be applied for all the products. If not, it is also possible that you design for upcycling. In this way, what happens is that the concentrating on producing objects that can either be kept for upgrading them as the initial item of their use ends, or rather maybe appropriate them to make good use of the items. And in some cases, of course, you can easily design some products for the biodegradability. That is, the informational signage can do it with homage to things made from the natural materials that they can decompose without harming the environment. Not only that, we can go for the product as a service model. So the manufacturer can render a service to a buyer rather than taking care of an outright ownership transfer. So it's again an option to have a lease or maybe to subscribe to a product nowadays instead of purchasing it. If not, we can also think for a design for the resource efficiency, that is in minimizing the material and as well as the energy wastage in the production platforms. Or else you can think of a regenerative design that is beyond just sustainability. It can serve the matters of the necessity for the social development, in which maybe it might be either through improvement or maybe through the revival. And finally, I just wanted to just talk about the circular design, which is again a closed loop system. So it can consist of the creation of goods and infrastructures by the intention of reducing the amount of material fitting into the production efforts. So this is the last section of the presentation. So I just wanted to give you some examples from Sri Lanka. What are the existing circular economy initiatives happening in the construction sector? So as I mentioned earlier, so Sri Lanka has been actively pursuing circular economy initiatives within its construction sector and aiming to enhance sustainability, resource efficiency, and to reduce the environmental impacts. So one very good example is the Sri Lanka Sustainable Housing and Construction Roadmap from 2020 to 2050. So this is launched by the Ministry of Urban Development and Housing in collaboration with the UN Habitat, UNEP and UNOPS. So this roadmap actually provides a strategic framework to transition the construction sector towards sustainability and circularity. So where it emphasizes like waste reduction and recycling, resource efficient building materials, life cycle based design and construction, integration of clean energy and resilience measures. So this roadmap serves as a guideline for not only for the policymakers, but also for the regulators and the industry stakeholders to implement sustainable practices in the housing and the construction. Another good example is waste to energy projects. So there are many, and two good examples are the Karodiana waste to energy project. That is, this is a facility where it processes municipal solid waste to generate electricity, and whatever the residual bottom ash from the process is utilized in the road construction, aligning with the circular economy principles by repurposing the waste materials. And the other one is the KCHT power station, so which is located in the Mudrajavel. So this is again waste to energy power station, where it uses 630 metric tons of waste from Colombo and Dampa suburbs. So again, the bottom ash produced is repurposed for road construction and other applications, where it demonstrates the practical circular economy implementation. The third example is the INSEE EcoCycle Circular Waste Management Initiative. So the INSEE EcoCycle is the waste management arm of the INSEE Cement, so which has been a pioneer in promoting circular economy practices in Sri Lanka. So they have three key initiatives like co-processing in cement kilns. So they are utilizing the industrial and the municipal waste as alternative fuels and the raw materials in cement production, thereby reducing reliance on virgin resources and minimizing the landfill waste. The second initiative is a women-led material recovery facility in Putlam. So it is established under the PLEASE project, and the meaning is like plastic-free rivers and seas for South Asia project. So this facility focuses on collecting, segregating or separating and processing the post-consumer plastic waste, thereby contributing to plastic waste reduction and also at the same time empowering the local communities, especially the women. And the third initiative by the INSEE EcoCycle is a public-private partnership, so where the collaboration with the Ministry of Environment to repurpose the discarded materials like maybe carbon pens or toothbrushes, so that showcasing the innovative recycling solutions. And I found another circular economy initiative in Sri Lanka. So this is the Star Government Innovation Center that we called as a passive house retrofit. So this is located in Katunayaka, and this is certified as the South Asia's first certified passive house project. So by retrofitting an existing building to meet passive house standards, this project has achieved over 70% reduction in the annual energy consumption, and it has enhanced the worker comfort through improved indoor air quality and the temperature control, whereby it increased the thermal comfort and demonstration of the sustainable building practices in a tropical monsoon climate. So all these initiatives reflect the Sri Lanka's commitment to embedding the circular economy principle in its construction sector and fostering the sustainable development and addressing the environmental challenges. So as a key or the core concept, so if you take the circular economy in the construction, so there are key phases where you can integrate the circular economy into the construction sector. So starting from the project planning phase and coming to the designing phase, and then to the implementation and the construction, and after that, after the use and end of life. So if you look into the project planning phase, where you have the early engagement of the stakeholders, not only the engineers, not only the contractors, clients, as well as the architects, so that they align on the circular goals, and also about the life cycle things. So we consider about the environmental impacts and material flows over the entire building life cycle. And then we can also think about the circular business models. That means you can include services like leasing building materials or maybe designing the construction for disassembly and also material inventory so that you can use the databases in order to track the available reclaimed materials. So this is practiced in some other countries in Europe. So they are maintaining the material inventories and then anybody who is interested so that they can get all the information. And in the design phase, so you can design for adaptability and disassembly, as I mentioned earlier, so that you can ensure the building can be modified or maybe dismantled without major waste generation. And in the design phase itself, we can think of the material selection. Maybe you can prioritize the reused, recycled, or renewable materials because or maybe you can use material passports to document material origin and I don't think that we do have this kind of material passports to document the material origin properties and the future reuse potential etc in Sri Lanka, but in some other countries they do have this kind of information or documents available. And also we can think of using technology where, for instance, you can think of the building information modeling, which aids in integrating and also tracking the circular strategies. So when it comes to the implementation and the construction, so there are efficient construction processes where it can reduce the waste, and also at the site itself, you can go for the sorting and you can reuse the materials. And also the modular construction, if you consider those techniques, can support future adaptability. And the last stage is the use and end of life, where the maintenance and repair strategies to prolong building life. And also we can think of the deconstruction planning at the design stage itself in order to recover the valuable materials at the end of life, and also think of the reuse pathways where we can integrate reclaimed materials back into the future projects. So the last slides are, I just wanted to give you an idea or some information regarding a framework that we can think of where we can apply for the construction industry. So just this is called the RISE framework. So that is the RISE means research and realize, implement, support, and enable. So I have included the categories of the framework like research and realize. So I have just given some examples of interventions where the research and awareness, also the knowledge development and expansion, sometimes the discussions like talks, like these kind of talks, and also the workshops or education and community and social involvement can be used under this, under the research and realize. And not only that, going beyond so that we can implement, that is the assessment of materials and energy flows for their quantities, footprints like carbon footprint, or sometimes we call talk about the water footprint, etc. And also the waste quantities and quality, structures, design, and the process of or the building model itself. And support means the financial incentives may be given by the government or maybe the private sector, and funding maybe the subsidies that we can motivate the industry to go for the circular economy in the construction sector. And also we can think of the taxes where you can impose taxes for certain negative practices that they are doing in the construction, and also some quotas or public procurement, etc. And enable means where you can have enablers like application of the laws or directives and regulations, maybe the technologies or some material passports that I mentioned, so information sharing systems and tools, etc. And also about the collaboration and partnerships among actors. So this is a very crowded slide, I would say, but I just wanted to include everything into this slide. So this is about the RISE framework indicator suggestions and descriptions where we can apply maybe to a certain country or maybe to a region. So you can, these are actually positive indicator suggestions where you can improve the circular economy applications or principles incorporated into the construction sector. So a number of academic laboratories involved with the research on circular economy. I think we are having circular economy related programs developed in Sri Lanka, and also apart from that, we can think of the laboratories and do the research, etc. And also we can think of the number of academic platforms and panels where the students as well as the researchers sharing the outcome of their work and ideas regarding the circular economy, and where they can discuss about the circular economy applications. And also the number of exhibitions or projects held concretely demonstrating circular economy strategies in the built environment. So reusing building construction, maybe the architecture, maybe the design with reuse elements, etc. Also, we can think of the number of green supplies, number of green deals, and also the number of partner construction companies involved in the circular economy projects who are rethinking their production and business models according to circular economy principles and aim the implementation of the circularity, etc. So there is a huge list I have included here. So sometimes you also can think of the reverse logistics and take back schemes set in place so that the waste, whatever after use, you can return it to the manufacturer or some other way that you can safely hand it over without dumping it into a curbside waste bin or maybe into a landfill. So so in summary, what I wanted to convey is in our current economy, we take materials from the earth, we extract all the natural resources whenever and wherever possible, and then we make whatever the products that we require from them, and eventually throw them as waste, so which is the so-called linear economy. So global construction is rapidly innovating and sustainability and the technology lead the way. So if you look into the Sri Lanka's construction sector, it is recovering, but it needs innovation and better economic stability, so that if you embrace the green practices and also the digital tools along with the circular thinking and design, they are crucial for the future resilience in the construction industry. And by contrast, in circular economy, we stop waste being produced in the first place, and wherever possible, reuse the materials and then recycle them as the basic principles of circular economy. So still there is a room for improvements through innovations, and also we need to think of the policy level input to be considered in the circular economy applications. So I think that's all from my end. So if you have any questions, we can discuss. And I think so. Thank you very much for your attention.
Thank you, madam. And if you have any questions, please ask them now.
Madam, can you explain that passive hives concept little bit? Excuse me, madam.
Sorry, I was muted. So passive house concept is actually, it's a design and construction standard that we see in many European countries, that is focusing on energy efficiency and also comfort and affordability. So what they do is they are trying to achieve the thermal comfort with minimal heating and cooling by using insulation, sometimes using air tightness. And also they are thinking of, at the design stage, they think of the appropriate window and the door design and the ventilation systems with heat recovery, etc. So that they are not using the energy, so that whatever the energy that is there, naturally they are trying to use. And if you need to heat, they are doing it, and maybe by the air tightness, and if you need to cool, that is done by the usual or the natural ways. Not like they are using like mechanical heating or cooling systems. They are just using it in a passive way.
Okay, madam. Thank you very much.
Is there any others to have any questions? Thank you all for joining us today for this insightful Green Talk. A special thank you to our esteemed resource person, Dr. Chamila Dias, for sharing your valuable expertise and shedding light on such an important topic. To our audience, your active participation and thoughtful engagement made this session even more impactful. Let us take the knowledge we have gained today and apply it to drive positive change in our communities and beyond. Together, we can continue to champion sustainability and work towards a greener, more resilient future. Thank you once again, and we look forward to seeing you at our next Green Talk.
Thank you very much, madam.
Thank you.